guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we will be looking at trigonometry. Before we start, please do not fail to perform an LSS. That's like, share, and subscribe. Also, just to point out that in this video we'll be only looking at right angles triangles. If you want me to explain triangles that are not right angled, which include the sine and cosine rules, that will be done in a later video, but not in this one. Also, make sure your calculators are in the degrees mode. This can be done by pressing shift in mode and going to 3, which is represented by DEG, which is degrees. This can be done on the Casio scientific calculator. So without wasting much time, let's get started. Now, before we start solving the questions, let's have a look at what exactly is a right angle triangle. This is a right angle triangle. How I know it's a right angle triangle is because I can see that there's a 90 degrees here. Now note that it doesn't have to necessarily be in this shape. It could be something like this. It could be something like this. The main thing is that there is a right angle in it. So, continuing, the next thing I know is that the longest side in a triangle is the hypotenuse. So this side of length is known as the hypotenuse. P-O-T-N T E-N-U-S-E. That's the hypotenuse. Now, in these kind of questions, 99.9% of the time, you'll be given an angle. Let's say the question gives you this angle and says this is 33 degrees. Now, this is just an assumption. It could be any number. When it gives you an angle like this, you should know that the side opposite of this angle is automatically known as the opposite. So in this case, here's your angle, and the side opposite to it is this side over here. So this is your opposite. And then there's only one side left of the triangle, and that side is known as the adjacent. Sure if this is the right spelling, but it is known as the adjacent. Now, note that the hypotenuse is always constant. It's always the longest side of the triangle, the right angle triangle. However, the opposite and adjacent can change in between them. For example, if this angle here was given as maybe 45 degrees and the angle over here was not given at all, it was left blank, you didn't have anything here, then your opposite would be over here. This would have been your opposite. Similarly, if that would have been your opposite, then this would have been your adjacent. So that is basically how a right angle triangle is bisected. You have your hypotenuse, your opposite, and the adjacent. You have your right angle here. They'll probably give you one of the angles, either this one or this one, probably leave the other one blank. Now, moving on, there's a mnemonic that's really famous and most people know it. However, some people do struggle with actually knowing how to use it. It's known as SOH, CAH, TOA. Now, you may be wondering how exactly this is used. It's used in a way that this, and this are used for different purposes. Let's look at SOH first. If I'm using SOH, I'm basically just saying sine x is equal to opposite over hypotenuse. where x is the angle that they have given to you in degrees. So basically, you take your opposite divided by the hypotenuse, and then you can take the sine inverse of that if you're trying to find the angle, or if you're given the angle and you're trying to find, say, the opposite, then you can just cross multiply the sine and the sine of the angle and the hypotenuse, and you get your opposite. Similarly, cos is cos x equals to adjacent over hypotenuse. Again, x is the angle in this scenario, and similarly depends on what you're finding. Then lastly, we have TOA. This is basically tan x equals the opposite over adjacent. Now that we know what we have, we need to make sure to know which one we need to use. So obviously, from the diagram I had over here, let's say we knew the, okay, you know what, let's make a new diagram here. It's not going to be accurate, but I think we can get the idea. Let's say this was 90 as it is. They gave this to be 45 degrees. They gave the hypotenuse to be x, and they gave this side over here to be 10. Now you need to know which one you're going to use. Are you going to use SOH? Are you going to use CAH? Or are you going to use TOA? Now we have a hypotenuse. That's what we're trying to find, the hypotenuse. The angle they gave to us, the opposite of that angle over here, this is the opposite. And then of course this side over here is remaining as the adjacent. So we know that we're using hypotenuse, but then which one of the opposites or adjacent are we using? And the answer is we're using the adjacent, because we know the adjacent, and the adjacent is 10. We don't know anything about the hypotenuse. The opposite. We have no idea what it is. We don't know the magnitude of it. So ultimately, we are using hypotenuse and adjacent. And the part of the mnemonic that connects hypotenuse and the adjacent is CAH. CAH. This is cos x equals to adjacent over hypotenuse. Yeah, and that is basically the ground foundation of a right angle triangle. So let's move on to a few examples. Let's look at question A. The first thing you should do when you look at such a question is know what you need to know, what you have and what you need to get. As you can see, the x is the hypotenuse because it is visibly the longest side of the triangle. Also, another way you can know that's the hypotenuse is because the side is not touching the right angle triangle, the right angle of the triangle from any side. Now, they gave us 38 degrees, and the side opposite to that, this become the opposite. And then this obviously remains as the adjacent. So we don't know anything about the opposite, so this automatically gets out of the equation. So we're looking at the hypotenuse and the adjacent. And what connects them in your SOH, CAH, TOA. So your opposites are gone, opposite, so this leaves, so you have cos 38 equals your adjacent, which is 13.5 over hypotenuse, which is x. Note that the angle that they give is basically over here. Now, to find x, the best thing we can do over here is cross multiply. So if we cross multiply, we have x into cos 38 equals 13.5. Your x is then 13.5 divided by cos 38 And lastly, putting that in your calculator, x 13.5 divided by cos 38. This would give you 17.13 centimeters. Be careful to work in the units that you are. It could be centimeter, it could be meter, and also to how many decimal places. In this occasion, I took it to 2 dp. That is your final answer for this. Moving on to the next example. Example B. Again, let's bisect this first. We know that this side over here is the hypotenuse. Again, it's the longest side visibly, and it's also not touching the right angle. Now, we've been given this angle over here, so the one opposite to this is x, so this is our opposite. And then this remains, which means this is our adjacent. So, we know that we're using the adjacent because we know the adjacent is 5. We know that our opposite is x, but we don't know anything about the hypotenuse. So that means hypotenuse is out of the equation. And from your SOH, the mnemonic that connects adjacent and opposite is tan. So we have tan 26 equal to opposite, which is our x, that's what we're trying to find, over our adjacent, which is 5. Then simply, we now have to find x, we just cross multiply. X is tan 26 times 5, and our x is tan 26 times 5. That's 2.44 centimeters to 2 decimal places, and that is your final answer to that question. Let's move on to our next example. Let's call this example C. Now again, we bisect this. We know that this side is the hypotenuse. We have been given an angle, but we don't know that angle. For knowledge sake, Okay, so for knowledge sake, we know that this angle, this sign over here, is known as theta. You can write that out, or you can just say theta, it's known as theta. That's what we're trying to find. So obviously, the side opposite of this theta is our opposite, and that remains with this as our adjacent. Now, again, we know nothing about the hypotenuse, so that goes out of the equation. We know our opposite to be 8.5, and we know our adjacent to be 7.2. So we connect these two, and we connect these two by using tan as well. So eventually we'll have tan x, or rather we can write tan theta. This can be tan theta equals to opposite, which is 8.5, over our adjacent, which is 7.2. Now you may be wondering how we'll get theta, because we can't cross multiply, because our unknown is not on the right side, it's on the left. What you can do in this case, using your algebra knowledge, is you know that theta is basically the tan inverse of 8.5 over 7.2. When you take tan, sine, or cos to the other side of the equation, it becomes the inverse of it. And putting this in your calculator, this should give you tan inverse of 8.5 over 7.2, that is 49.73 degrees to 2 decimal places again. Now, in order to put in the inverse of a tan or sine function, all you have to do is just press shift before pressing the desired function. Now, that is the answer to this question. Moving on to the next example, our final example of this video. Let's call this example D. Now, this might look a bit complicated because it looks like we have two triangles. We have this triangle over here and we have this triangle over here. So in order to make it easier, let's see what it's asking for. It's asking for, we need to find this angle theta. So automatically this side over here becomes our opposite, and of course we know that this side is the hypotenuse, this side is the hypotenuse, but we have no information about it, so I'm not going to write anything because I know that we're not going to be considering that side at all. And if we know that's the hypotenuse, we know that this side over here is the adjacent. So obviously we're connecting opposite and adjacent again using tan. However, we don't know our opposite, so we need to find our opposite first. But we do know that this triangle over here is something like this, 4, 5, and this is what we're trying to find. Automatically, you can see that we'll be using Pythagoras theorem. For those of you that may not know what Pythagoras theorem is, it's basically a squared plus b squared equals c squared, where c squared is the hypotenuse side and a and b are the other two sides of the triangle. So as you can see, we know that our c is 5 because this has been given as a hypotenuse. So we can say 4 squared plus x squared, because that we're trying to find, equals to 5 squared. We know that x squared is equal to 5 squared minus 4 squared. That's the same as x squared equals 25 minus 16. That's the same as x squared equals 9. X is the square root of 9, which is 3. So now we know that our opposite over here, opposite is 3, and we can finally complete the equation. So this becomes tan theta equals to opposite, which we just found out to be 3, and our adjacent, which is 6. Finding theta, this is the tan inverse of 3/6. Theta is equal to, bring down your calculator, tan inverse 3/6. This is 26.57 degrees to 2 decimal places. And that is your final answer for this equation. So thank you for watching, guys. Please do perform an LSS, like, share and subscribe. Please don't forget to comment below to give me any feedback or any questions you may have. And thank you for watching, guys. Have a nice one.